class. Okay, so last day we talked about the partitions, the volume and partitions. So in many operating system we see that there are different volumes like C drive, E drive, D drive, and so on. So those drives are nothing but we call them as volumes. Sometimes we talked about yesterday that sometimes we can have one disk and we can create several volumes out of that. Sometimes we can have multiple disks and we can put them together in one volume or more than one volume depending on the scenario. So volume helps us in both the scenarios. One disk, and if you want to create a C drive, E drive, D drive, and so on. The other case, we have say 10, 15 or 20, and we want to group them together. Like say, out of 20 disks, say 2 disks or 1 disk, I can keep it for booting, and then the rest of the disks can be put together for data section. So that we can store our data, and that can give us a huge volume altogether. Sometimes in Linux-based system, we can have, say, for user home, we can have one partition or one volume. We can have a data section or backup section where we can have more volumes and so on. So this is what we discussed. And in FAT, we discussed that normally in a FAT or basically in DOS partitions, we normally allow only 4 partitions. So usually a DOS based system is having 4 partitions, only entry for at the start or in the first sector of a disk. If it is DOS based partition, we can have 4 partitions available. So we can have entries for 4 partitions. But we know that in some cases we have more than 4 partitions. Then what we do, we create at most 3 partitions as a normal partition, and then the 4th one is called as extended partition. And then again in extended partition, we can have again 4 more partitions. And if you further want, then in one of the extended partition, you can have the similar approach. I hope you are getting the idea. This anyway we had discussed last day. I'm just doing that. So in DOS-based system, we can have this by disk. So here we allow only 4 partitions out of this. So 1 partition, 2 partition, and say what we can do for 3 partitions. So for first, second, and 3, we can have entry here. So 1 can be made entered here, 2 can have an entry here, 3 can have an entry here. But after that, if we want some more partitions, say if I partition them again in 3 partitions, then as 4th we allow an extended partition. So we call them as extended. And then in extended one, we again create this sort of table in the first sector of that extended options for 4 more volumes. So again, now you can say that this is the first one, we can keep, this is the second information we'll keep. And if there are no more, only third, then we can place the third here. If you want to create more, then similarly, you can create one more extended and you can continue doing this one. So that's a very simple idea in the DOS-based system. So this is an example you can see. So we have 3 partitions which are primary, as I told. So without any hiccups, you can create this. But if you want to extend this more, then immediately you create an extended version of partition, and in the extended version of partition, you can continue doing that. Now, last day we also talked about, consider we have a data set, and these are the things. So when we talk about, like when I have drawn this one, so this is basically, this whole is one sector, say, and in one sector we know that we have 512 bytes. If we assume that our sector size are by default 512 bytes, so each sector is of 512 bytes. So what goes on in this 512 byte? Because these 4 entries will require some space, but not all these spaces. So we say that up to 446 out of this 512, if this disk is bootable, then that information is kept. So if I now just enlarge this space, say अगर इस space को enlarge करें हम लोग, so then we can say that say this is like 512 starting from 0 to 511, then up to 446 to 0 to 455 we have boot information, or this is the bootable information. So if it is a bootable disk, so booting sequence will be stored here. What is needed for booting, that will be kept here. After that, we have this partitions basically. All this partition information is shown after that. So what are there in this one? These 4 partitions we talked about. So in each partition, these are the things, in each partition, these are the things we need to keep. And you can see each partition is of 16 bytes, 16 addresses. Okay, 16 byte basically, because we have a byte addressable. So 16 byte and byte, 16 addresses. Each address is basically a byte addressable. So 16 different addresses we have. So 16 addresses. So that's why this number will be 446 plus 64. I hope is 512. So now you can understand that this space can be converted into 4 equal size partitions. And this is what this refers to, this area, this small area. This area is basically this area or this sort of small area. Before that, we have boot sequence, which is not shown here. So in this area, what happens or what goes on inside this? So we know that this is total 16 byte. This is 16 byte, this is 16 byte, and this is 16 byte. And if you see what goes inside 116 byte is this one. So first 0th byte is basically bootable flag. So whether this disk is bootable or not, whether the first partition is bootable or not, then that information, so we have the first byte which is reserved for that. So if it is 1, we know that the partition we are talking about is going to be a bootable one. If it is 0, then it is not a bootable one. And one says starting CHS address. So we have talked about the CHS address in earlier disks. Since disks are arranged in this manner, I hope that you all know this basic structure of disks. So we have concentric circles, and we start our addressing from 0. So this is our 0th track or 0th cylinder, and this is one sector. So sector number 0, then sector number 1, then sector number 2, sector number 3. So this whole disk will be divided into some number of sectors. Say if we have k number of sectors or s number of, so basically here s number of sectors. So that is what in CHS. When we talk about CHS, so the last S is the number of sectors in one cylinder. How many sectors are there? Then we have heads. So we know that these disks are platters, several platters kept one after another. So one plate kept after another plate, kept after another plate. So if we have say 7 or 8, if we have 8 plates, then that means, and these plates are addressable from both sides. So we can write data on this plate on both sides. So on top as well as on bottom. So we will have, if we have 8 plates, that means we will have 16 heads. So this H refers to how many heads we have, or this is the address of head. Address of head. So normally say if there are 16 heads, so we can use 4 bits to identify uniquely each head. So which head we are in? 8 heads and 8 heads are on bottom. So we have a sequential numbering. So say if the bottom head of the lowest one is a 0, then on top of that will be 1, then so on, next one, then next one, and so on. And the C refers to the number of tracks or the number of cylinders. So how many such tracks are there? Like 1, 2, 3, 4. So in this example, I have drawn 4 tracks or 4 cylinders. Why cylinder? because if you view them together, you get a cylindrical view. So how many cylinders are there? So for that, we use cylinder. And these numbers are basically, this is, I think, this is 10. There are total 10 cylinders, 14, and this number I'm forgetting, but altogether you can address only 8 GB from this. The total count 8 GB. How many bit? This can be, what can be the length of this one? Can anyone tell me?
33 bit.
33
bit, sir. Bit.
Okay. Bit. So okay. So 33. This total count will be C plus H plus S will be 33. Okay. Because say there will be some count for cylinder, some count for head, some count for head. So sector. So altogether this number, this length is going to be 33, because with 33 bits we can address up to 8 GB, and that's the limitation of CHS. Later on, we use LBA addresses, logical basically. So in LBA addressing, instead of addressing with sector, track, and sector, head, and cylinder, we say that okay, all the sectors are now, say, if it is assumed that all these sectors are given a unique number. So starting from sector 0 on the bottom side of lower disk, then sector 1, 2, 3 on the lower side, then we get on top of that the upper part, and then we can count from the number where we ended last. So if there are total, say, 100 sectors in the bottom one, then 100 will be on top one also. So next, if we go to third platter, then we will start from 201, then 300, and so on. So we'll have a single addressing for all the sectors. So we do not consider how the disk is organized. Basically, we forget about this head. Yeah. So now if you see this, just to make compatibility, so you can see here that this total addressing scheme given here is 1, 2, 3, 1, 2, 3. Will it be 33? It will be 24 only. The number of addresses given here are 33, I think 8 plus 8 plus 8. That's all. 24 bit ही होगा ना जी?
Yes, sir. 24 होगा.
Say, sorry, 2 to the power 10 is 1 MB, KB, sorry. MB, yes, you were right, 2 to the power 10 GB, and then 2 to the power 3 is 8. So why this disparity? ये प्रॉब्लम कहाँ हो रहा है? You are right, 33 होगा, लेकिन यहाँ 24 बिट का क्यों दे रहा है? Less than 8 GB. If it has to be less than 8 GB, then how much we can have? We should have 33 bit address. CHS address. So this is what, so 120, there are no hard disk with 128 platters. So basically 10 bits for cylinders, then we can address up to 0 to 1024 cylinders. And then we have 0 to 254 heads. That means 7 bits. 8 bits, sorry, 8 bits. So 10 plus 8, how much? 18, and this is 6, 24. So it is coming out to be 24 only. क्यों हो रहा है ऐसा? 10, this is 10, this is 8, and this is 6. 6, na? ठीक है ना नंबर?
Sir.
Yes, sir. Yes, sir.
Start at 0. Each sector is okay. We have forgotten about the bytes. हर sector में भी तो bytes है ना? That's where I made a mistake. Actually, I considered about the sector addressing, but each sector. So with 24 byte, that's where I made the mistake. So 24 हुआ 2 to the power 24, and then
9.
each
9
sector is of length 2 to the 5 12, so it will be 2 to the power 9. So now that's 2 to the power 23, 2 to the power 33. Is it okay to everyone?
Yes, sir.
Yes.
I just forget about the second part. हर sector का भी एक तो size है. हर sector, each sector is of 512 bytes. So that will have 2 to the power 9. So it's basically coming out to be 2 to the power 33, and hence we will have the disks will have size lesser than 8 GB only. So we can address only disks which is lesser than 8 GB. You can see here. So then the other one was logical block addressing. As I told, in logical block addressing, normally the modern BIOSes, they use continuous values. So continuous values means which is not shown here. So they start from 0 and then they continue for all the sectors. So now you can assume that what we were talking about here. So this starting CHS address will be 3 bytes, and then partition type, which is 1 byte. We'll see shortly. Ending partition, again CHS, this is an CHS address, so it will be 3 bytes. And then starting LBA address, as starting LBA address, again this will be larger, this has to be larger. So we have 8, 9, 10, 11, so 4 bytes. And then size in sector. So you can again recall, this is 4 byte for addressing the sectors. So altogether this will be power 4 means 32. So 2 to the power 32 into 2 to the power 9. So LBA can address up to, isn't it? 4 bit का address है LBA में, 4 byte का, sorry. So 2 to the power 32 sector addressing के लिए and 9. So this is 2 to the power 41. So they can address up to terabytes of data. In fact, 4 terabytes of data. Isn't it?
Yes, sir.
So this is what goes on in each sector. So ये जो 16 बिट है, ये 16 बिट ऐसे डिफाइन हुआ और हर एक के लिए वैसे ही होगा. So जो यहाँ पे वैल्यू दिख रहा है, let me just, so this, sorry, so this 16 byte will be something like this. So this 16 will be for this first partition. This is for second, third partition, fourth partition. So for every partition, we will have 16-bit entries like this. And if you look into whole 512, so this is how this whole 512 look like. So starting from 0 to 445, as I told, 0 to 445, we will have boot code. Then 446 to 461, we will have partition table entry 1, and then the partition table entry 2, then 3, then 4, and the last one, in fact, here, last 2 bits, which is 510 and 511, basically some which is called as signature value. So if it is a DOS partition, then they will have this value AA55. And last, we also talked about this example that, okay, given a disk, say if we have an example, have anyone downloaded or found this data, disk 3.dd? Is there anyone? उस लिंक पे या कहीं लिंक पे मिला ये डेटा?
Yes, sir. Yes, sir.
मिल गया अभिषेक?
Yes, sir. आपने दिखाया था ये लिंक क्लिक करके.
So have you downloaded?
Yes, sir. I have downloaded it.
Okay, thank you. So tomorrow I expect that you will demonstrate all these things.
Yes, of course, sir.
Okay, so these examples are available. Last time I had shown that in this book they have given the link. So disk 3.dd, say that's an example disk which is given there, and in this disk there are certain partitions. So if you just issue again a dd command, so which is the input, if stands for input, input is disk 3.dd, out this is the block size, so which is 512. We are not skipping anything, and count equals to 1, so we are counting 1, and xxd, so we are piping this command to xxd. If you do this, you will get a lot of entries. In this book, they have just given this snapshot. In fact, when you will run, you will get the whole entry starting from 0 to all this up to 496. So since the upper part, we know that upper part we have the boot sequence. So they have removed this one. They have hidden that one. Now let us see this 384. So 384 there. So if you continue here, so you will find out this is 384. So 384, 5, 6, 7, 8, 9, 10, 11, sorry, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, and then 400. So 400, this will be 415, and then 400, this is 415, okay? And then 416, we need to go up to 445. So we know that 446th entry, that's what we talked about here, that 446th entry will be starting the partition table entry. So count here 446th entry. So 446, this is 448. So this will be 7, this will be 446. So 446 entry you can see is 0001. So in fact 446 is 00. And if you look into this value, the first byte, 446 byte is bootable flag. So 446 is 0 here. That means this is not a bootable disk. The next 3 entry, as we see here, are starting CHS address. So we have 01, 101, 00. These are the starting address of CHS, which in this case is not in fact required. Then the next entry you see is partition type. So fourth entry is partition type. Fourth entry is partition type. So fourth entry is this one, because this is first 1, 2, 3 entry. This is the partition type. So 07. Now 07 represents a partition type. If you see here, this is the type partition type, which is available for reference. And now we can see that 07 is basically NTFS partition. So that's clear that the first partition in this disk is of NTFS. So this partition is NTFS partition. So in fact, this is not the partition, this is just an representation for that. So wherever this partition will work, it will be an NTFS partition. And then the next entries are partition type. So we have again 3 bits, which is a CHS, we can ignore. So this 1, 2, 3, we can ignore. The next 3F000000. So this one is the starting LB address from where this partition starts. And this is an little endian machine. So we have to reverse these bytes. So the real byte will be 0000003F. Okay, you can see here, they have written here. So 0000003F. So this is in decimal, this is 63. So from 63rd sector, in fact, this partition starts. Okay, and then the next entry will be after partition. What was the next value? Next value was size in sector. So next 12 to 15. So I think up to here. So 12, so 12, 13, 14, 15. So this is the size. And again, since this is little endian, we have, because this is an Intel PCs, which is little endian. So it will be 001F 6041. So 001F 60 and 41. So this is the size of that partition. So that gives you a partition. So if you have that disk, so now you know that first partition in that particular disk. So if I just again recreate the structure for that disk. So if I assume that this is my complete disk, so now you can assume that this is starting at 63rd location. So we are not sure about the first 0 to 63rd. So starting at 63rd, and then this length is this much. So this is total number of sectors which is taken up by this one. So you can add this number 2056 257 257 plus 63 कितना हो जाएगा 10 12 3 6 2. So this is the ending address 205631 in fact. एक कम से स्टार्ट होगा ना, because starting with 63 total size, so -1. So 63 is included, hence this will be -1. So this is an NTFS partition in this disk. Then if you see into the other one, अगर उसी तरह से दूसरा देखो तो then the next entry is again this is 80. So this is 80 means probably this is bootable. So this is non-zero. So next जो partition होगा वो bootable होगा. From where that next partition starts and what उस partition का type क्या होगा? So that will be 83. So 83 partition is a Linux partition. So next partition जो होगा वो एक Linux partition है. कहाँ से शुरू होगा वो partition? तो यहाँ से शुरू होगा 001F6080. So 001F6080 and this is this address. वहीं तक गया, हाँ, तो उसके बाद वाला जो है 320 से वो शुरू होगा. आई थिंक 320 ही होना चाहिए, 63 छोड़ दे रहे हैं. सो दिस इज 20. ये एक पार्टीशन है, यहाँ से नेक्स्ट पार्टीशन शुरू हो रहा है. दिस इज EXT पार्टीशन, लाइनक्स पार्टीशन, सॉरी लाइनक्स में भी बहुत सारे हैं. सो लेट मी जस्ट राइट दिस इज लाइनक्स पार्टीशन. ये कितना चलेगा, that's count we can find out from here. So 0003 2F and CD. If you convert it into decimal, this is itna lamba hai, 208485. Okay, so if you again add this number with this one, then probably you will get the location. So यहाँ तक होगा, यहाँ तक होगा, कितना होगा, this plus this count. So this is a Linux partition and this is bootable. So this can, here the system can again boot it. Then similarly the next one you can see, again next one is an extended Linux partition. Uski size kitni hogi, the size, and that one is not bootable now. Next one is not bootable. Although that is again a Linux partition but not bootable. Right. And in that case the address will be, so these are this is the size of that disk and this is the starting address of that disk. The last one is again not bootable and it is of type 05. So the partition type. So 5 is basically a Microsoft extended partition and it uses supports CHS. So if it supports CHS, now you can assume that now we can take care of the CHS addressing, because that's going to be a very small partition. So you can create, in fact in this book they have not given, if you want to see, we can create that whole partition. So the partition entries, I'm just writing it down, this example mein. So let me just complete one. So this was 63 ending at this was ending at 2056320. 6 3 2 0. The next one was 2 2 5. Sorry, 2 2 6. 2 2 6 5 1 6 5 1 6 5. And the next one was 3 2 9 3 3 2 5 3 2 5, and the ending value was 8 0 2 9 2 8 6 9. And now this is NTFS, this is Linux, this is again Linux, and this is extended partition. Extended partition, primary extended partition. You can see here, that's what Microsoft extended, so Microsoft primary extended partition. 05 was extended partition. And as we discussed that if we have more than 3 partitions, then normally the last one is an extended partition. And if you continue this one, so they have again given further. So this was one. Then again, if you now you know that the extended partition ended at this location. So if you want to further see what is there in that extended partition, so you can issue another command like this. If you skip this one, the earlier part, if you skip till that one. So earlier, if you recall, if you see that the last one from where extended was starting is this one. 329 3325. This is where the extended partition was starting. So if you want, because extended partition is again something which may create some more partition. Is it okay? Because that's what we were discussing for yesterday also. Today also I have already told so many times.
Yes, sir.
Yes, sir.
Because this extended partition is somewhere, means again where we will create some new partition. So if you want to see now what is there in that extended partition, so again you can issue a command like this. So if almost same command, but we are skipping the first part. Okay, we are skipping. Now we have decided that these are the earliest are my normal partitions. So I want to now check into this partition. What is the structure of this partition? So we are skipping this and the command is same. So now if you go ahead with that, you see that you get something like this. Okay, and then again if you start like 446, so the 446th entry is 00. That means the next partition is not a bootable one. That's for sure. Normally in extended we hardly have bootable. Then the next one is you can check this one because that's where is more important. So 83 is partition type. So partition type 83 partition type is again a Linux partition. So we know now that within this extended we have Linux only. So we have one Linux partition in that extended. And in that extended partition again the total length of that partition will be this one and start obviously at this address. So it starts at this address and the total length is this. Okay, so you can again think of key. So where is this address? So you can convert it into binary and you can check key where it will go. Okay, so that basically is if we go, this is in fact 000. This is 63 only because this is 3F. So this is 63. And then this one is basically 63 with respect to, or basically with extension of this extended one. And then the next one is this. So you will find that there is one more Linux one more extended partition. So there is one Linux partition inside this, and then one more extended partition in this. And if you again, and there are only 2 entries. So last 2 you can see is 00 only. So there are that confirms that these two are non-zero. That means in this extended we have two more extended partition. So this one is a Linux one because first one is 83 and second one is further extended because 05 is for again an extended partition. So we have one more extended partition here. And if you again want to see what is there in that extended partition, so you can again issue something, a very similar command by skipping the other part, and you can see if there is something. So and you can see that this is the next value, this is the address, next address from where the next starting starts, and this is the ending one. So if you add them and if you reach to the end of this whole disk, that means that there are no. But if there is any space, like what we can see from this one is 4096 575 and 10, so this is going to be hardly 5000 5 something 5 and something. So there will be another space which is still space, in fact unallocated. So this space is unallocated. So this is Linux one, this is extended partition, and this space is unallocated because we are yet not reaching to the end of that disk. So if that's the scenario, that means we have some more system, some more information. Yes. So last there, so they have calculated it here. So this is the last one plus 63. So this partition Linux starts from, so 63 is slack here. So they have kept. The next starts from this place and ends at this place. This plus size, this one. So this is the size, last one starts and then further extended. So that starts at this location and ends at, so it ends at almost the end one. So it goes up to the end of this one. So there is no slack as such. So this is how this whole thing looks like. DFS, then Linux, Linux, then primary extended, and inside this primary extended we have Linux extended and swap extended. If you do the whole analysis of that disk, what that disk 3.dd, and as I will expect that next day in lab class you at least go through this example and some more disk 2, disk 1 dd you can download from that website, and you can really see this. Because we have, why we are discussing this one, we are, remember, we are not discussing the file system, we are not still going into files. So far last class and today's class we have not talked about how files are organized into this, remember. So don't confuse this that I'm talking about or we are talking about file analysis. We are talking only about the disk analysis. Exactly, given a disk, what file systems are there onto that disk and how many such partitions are there, where there is any gap between two partitions or not. Say in some cases, yesterday we talked about that if there is a space, say if there is a gap, so if we have a partition here, say one partition start from this and through this, so this is an occupied place, and then we have one free space, and the next partition goes say from here to here. So this is a free space and this space is unallocated. So you can see this through this tool that there is some unallocated space. And since it is an unallocated space, the genius or basically the bad guys who are trying to hide something, or even some good guys also in some cases, if they try to hide something from the other people, they can utilize this free space and they can write their files there, or they can write their content there, which normally will not be visible to other people's. Okay, so we are just discussing about this. Now, how to write, how to analyze this, that file, how to open that file is a different issue, altogether different issue. We are only discussing today and last day, we are only concentrating ourselves exactly how these partitions are stored for DOS-based system, for to some extent some Linux-based system. Now I will move on to the Apple Macintosh based system. Okay, how really Macintosh does this. This is Now next go to the Apple partitions, exactly because now Apple machines are also becoming very popular, and they are very much in fact in common now as a personal computer. So they are replacing the Windows based personal computer, especially in laptop segment. You know that Apple's systems are penetrating too much in recent past. So how Apple maintains all this sort of partitions? So Apple has a different, although Apple's operating system is based on Linux. So the kernel of Apple's operating system is basically a Linux kernel, a Unix kernel. But the partition structures they use is totally different, which is not similar to Linux, which is neither similar to or Unix, and which is neither similar to the Windows. They have a very simple structure. In fact, the most simplest structure they follow. So what they do not have any restriction on the number of entries. What we see in a DOS-based partition, we have a restriction that we can use only 4 partitions. In fact, what they use the first sector of the disk to keep all the partition information. So there can be n number of partitions, and then they can maintain a data structure. Okay, they have one partition 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This can be a variable length of field. So there is no limit on that. So that they can keep the number of partitions. So all the partition informations. You have just seen the difficulty in a DOS-based system. So you have 4, then extended, then in extended again you have to repeat the same process. Then might be further extended. You have to repeat the same process and so on, which is not there in Apple disk. So in Apple disk, you know that if I am reading the first sector or just first few sectors, I can get all the partition information, and that's a very simple structure. You can see here how things are stored. So they say that 512 bytes, total 512 bytes of a sector are reserved something like this. So they have a signature value, and the signature value is normally 504D. Remember this, in this book, the entry what are there is a just similar command dd, and they have analyzed an Apple disk. If you look into this you do not need to reverse, because this analysis was done for an Apple disk which was configured for a Motorola Power PC. Again I am repeating, दिस डिस्क जिस डिस्क का उन्होंने यहाँ पे एनालिसिस किया है, इस किताब में जो दिया हुआ है, वो एक मोटरोला पावर पीसी के सिस्टम के साथ कॉन्फ़िगर था वो डिस्क. एंड सिंस मोटरोला पावर पीसी इज अ बिग इंडियन सिस्टम, इसलिए यहाँ पे जो जैसे है वैसे ही रहेगा. वी आर नॉट गोइंग टू स्वैप द वैल्यूज. बट अभी के जो मैक सिस्टम्स है, मैकबुक्स आते हैं, दे आर आल्सो कमिंग अप विद इंटेल पीसीज. नहीं जानते हो तो अभी इंटेल के साथ आता है. नाउ दे हैव कम अप विद देयर ओन प्रोसेसर.
यस सर.
सो अगर इंटेल पीसी के साथ, अगर तुम्हारा मैकबुक है और अगर वो इंटेल पीसी के साथ है, देन यू हैव टू रिवर्स इट अगेन, because when that disk was formatted and everything was written, it will be again that Indianness will be kept because of the PC structure. But since it was with a power PC, यहाँ पे उन्होंने लिखा है कहीं ये पावर पीसी के साथ था, हाँ, मोटोरोला पावर पीसी प्रोसेसर के साथ, एंड दैट्स अ बिग इंडियन ऑर्डरिंग. सो जो जैसा एंट्री है वैसा ही यूज हो रहा है. आई एम जस्ट टेलिंग इट सो मेनी टाइम्स, बिकॉज क्या होगा कि जब पढ़ोगे तो इसको भी तुम उल्टा करके रख दोगे बहुत बार कि हाँ उसमें तो उल्टा हुआ था. सो बी वेरी कॉशियस हियर. These are the values which are written. So first entry you can see the signature value, which is 504D. That shows that this is our PC or partitions information for Apple Macintosh system. Then these bits are reserved. Then 4 to 7, 4, 5, 6, 7. So 4 bytes they use for the number of partitions. So how many partitions they have, they keep that information in the first 4 bit. So you can now assume that the 101 was, let me इसको कॉपी कर ले. Can I copy it? No. कॉपी तो हो रहा है, नहीं हो रहा है। एनीवे तो फिर बैक फोर्थ करना होगा हम लोगों को। चलो, सो 0 1 was the signature value, then 2 3 is reserved, 4 to 7. So 0 1 2 3 4 5 6 7. So this gives us the total number of partition. So A means कितना हुआ 10, no 9
Sir,
10,
10.
sorry 10. So the disk which we are going to analyze have 10 partitions. Okay, so now you can see the difference between a DOS based partition and a Apple based partition. DOS based partition में हम जानते थे इस संख्या की कोई जरूरत नहीं थी, because we know that it's going to be 4 only and 3 will be the regular partition, fourth one will be extended. But it is differing, first thing. So 10 partitions we are going to discuss, we are going to see. Then 12 to 15, size of partition in sectors. So sorry, total number of partition. Then starting sector of the partition. So starting sector क्या है 8 8 9 10 11. So next 4 bytes are starting sector, कहाँ से शुरू हो रहा है. Then the next one is size of partition in sector, कितना बड़ा है पहला partition. Okay, size of partition in sectors. So this one will give us size of partition. So again this is 63, 3F means 63. Then name of partition in ASCII. Now that's where again it differs with the other systems, कि यहाँ जो पार्टीशन का नाम देते हैं उसको नंबरिंग, जैसे पहले वाले में हम पार्टीशन का नंबरिंग करते थे 0 1 2 3 4. Here they give a name, like you can see that the next one is this one. This is the name of the partition up to 65, and that name is Apple, and that is in ASCII format. So that's what they are saying. The next 14 to 47, so 14 15 16 17 18 19 up to 47, this is the, sorry, so इतना ही नहीं है, 16 to 47 यहाँ तक ये पूरा पार्टीशन का नाम है ASCII फॉर्मेट में. ये कोई सिंपल नंबर नहीं है कि पार्टीशन नंबर 0, पार्टीशन नंबर 1, पार्टीशन नंबर 2, पार्टीशन नंबर 3, ऐसे नहीं दे रहे हैं, हम पूरा नाम दे रहे हैं. So नाम लिखते हैं एप्पल पार्टीशन का, that comes like Mac drive. If it is normally this is the name now they use. So if it is Mac drive, so ये पूरा Mac drive लिखा रहेगा यहाँ से यहाँ तक. Then type of partition in ASCII again, कि उसके बाद 48 to 79, so यहाँ से यहाँ तक ये किस तरह का पार्टीशन है. So if it is Apple partition, Mac drive partition, जो भी लिखते हो अभी, that they will write in ASCII format totally. Then 80 to 83, starting sector of data area in partition. Now since Apple doesn't maintain a separate boot section, मैंने पहले वाले में DOS में क्या था 0 to 446 रिजर्व था बूट के लिए, अगर कोई बूटेबल नहीं है तो दैट वाज जस्ट क्लीन 0 था और कुछ नहीं था. बट यहाँ कोई बूट सेक्टर के लिए अलग से कुछ रिजर्व नहीं है, तो इसीलिए हम हर सेक्टर में ये देते हैं कि वेयर इज द डेटा स्टार्टिंग इन दैट पार्टीशन एंड साइज ऑफ डेटा इन दैट सेक्टर, स्टेटस ऑफ द पार्टीशन वेदर इट इज बूटेबल और नॉट, एंड देन स्टार्टिंग सेक्टर ऑफ बूट कोड, कहाँ से बूट स्टार्ट हो रहा है, साइज ऑफ द बूट कोड, कहाँ से कहाँ तक बूट कोड का साइज है, address code boot address of bootloader code. So that's what will go following this one. Okay, then boot code is position independent, yes or no, partition is readable, writable. You see if you have worked on Mac, so देखोगे कि Mac में बहुत प्रॉब्लम होता है रीडिंग राइटिंग के केस में. So you hardly, if you are in a specific place, अगर तुमने फाइल सिस्टम पे कुछ लिख दिया है, तुम अगर एक हार्ड डिस्क में उसको कॉपी करना चाहो तो मोस्ट ऑफ द टाइम यू विल फेल. अगर हार्ड डिस्क मान लो कि नॉर्मल हम एक्सटर्नल डिस्क जो लेते हैं वो अगर तुम्हारा फैट फॉर्मेटेड है या NTFS स्पेशली फैट में चला जाता है, बट इफ इट इज NTFS फॉर्मेट, देखे हो कोई इस तरह का प्रॉब्लम फेस किए हो, एंड हैव यू रिजॉल्व दैट इशू एनी टाइम?
Yes, sir.
Anyone?
Yes, sir. कॉपी नहीं होते तो
किसके
उसको
हो?
फॉर्मेट करना पड़ता है।
हाँ, फॉर्मेट नहीं करके भी कर सकते हैं काम हम लोग। एक्चुअली होता क्या है कि इफ यू आर हैविंग फैट 32 फॉर्म से फाइल, सो फैट 32 कि कितना हम कितना बड़ा एक फाइल हो सकता है, राइट? एक फाइल का साइज फिक्स्ड है। सो इसलिए क्या है कि अभी हमारे पास अगर कोई मान लो कि बहुत बड़ा वीडियो या लेक्चर्स वगैरह है, तो इन फैट 32 वी कैन नॉट कॉपी। इवन योर डेस्क और योर पेन ड्राइव माइट हैव स्पेसेस। अगर कोई बड़ा जिप फाइल है उसको तुम कॉपी नहीं कर पाओगे, क्योंकि वहां फाइल सिस्टम के कैपेबिलिटी नहीं है कि उतने बड़े फाइल को वो एड्रेस कर पाए। आई होप बाय दिस यू शुड बी अंडरस्टैंडिंग दैट अल्टीमेटली कितने नंबर ऑफ बिट्स अवेलेबल हैं एड्रेस करने के लिए। अगर उससे ज्यादा किसी का यह है जरूरत है तो नहीं एड्रेसेबल होगा। तो NTFS क्या है कि उससे बड़ा है। सो वी नॉर्मली गो विथ NTFS टू कॉपी बिगर फाइल्स। So normally, usually the hard disk, external hard disk, we go with NTFS partition. And NTFS partition is not recognized in Apple One, or Apple doesn't allow to be written to NTFS partitions. You can read from them, but you cannot write them. That's a policy which they have. So this is what all those sort of policies are written, whether that partition is readable, that partition is, because if a disk is mounted, इसका मतलब है कि वो एक वॉल्यूम मिल गया उसको। जब भी हम माउंट करते हैं ना तो उसको एक वॉल्यूम नंबर उसके साथ एक वॉल्यूम असाइन हो गया। सो यू कैन नाउ थिंक दैट कि अगर कोई NTFS पार्टीशन है, so that will be readable, that bit will be 1, but writable will be 0. So we are not allowed to write. So there are certain commands so by which you can make them writable, you can give them that permission, and that can be very much done even in Mac systems. And all these things, so they keep all this information, sorry here, so reserved, boot entry reserved, and so on. So all these are written in those 512 bytes code, and these are for Apple partitions. So here they had partition, no status of the partition कि किस तरह का partition था 88 to 91. So these are the entry, whether it's a valid entry, allocated, in use, boot information है, mount होता है automatically startup में कि नहीं, startup partition है या नहीं. So all these informations are kept here. In fact, the Mac partitioning scheme is easier. You can see here with simple, and they have, if you are using, again there are two issues कि अगर एक तो है कि हम मैकबुक और मैकबुक का ड्राइव को हम एनालाइज करना चाहते हैं, सो देन वी और हमारा ऑपरेटिंग सिस्टम जिस पे हम एक्सेस करेंगे दैट इज आइदर लाइनक्स और विंडोज, देन वी कैन गो इन अ कमांड प्रॉपर जो भी हमारा टूल्स है MMLS दैट वी कैन यूज. बट इफ वी आर हैविंग एन एक्सेस टू अ मैकबुक ओनली, हम मैकबुक से ही एक्सेस करना चाहते हैं उसको, तो इन मैकबुक दे हैव अ कमांड कॉल्ड एज pdisk, and through pdisk you can easily find out कि कितने partitions हैं उसमें. So you can now see that there is a partition 1 length this, then Apple driver partition, Apple driver partition, Apple driver partition, so many partitions, and then these are the free space, so that you can see this you can find out with that. The another one is a DMG file. Whenever you application in Apple system, you normally download a DMG file. In fact, DMG file is also a disk image file, so that's why the name is DMG, disk image files. So that the short form of disk image file. So again, disk image file is something what this DD is also. This DD is also a disk image file only. RAW is also a disk image file. So this DMG is also a disk image file. But this DMG file is different from other disk image files. In fact, this DMG file is similar to a zip file in Windows or tar file in Unix. So जो हम Linux में प्रोग्राम इंस्टॉल करते हैं वहाँ DMG फाइल डाउनलोड करते हैं. So वो DMG फाइल भी एक डिस्क इमेज ही है, बट इट इज वेरी मच सिमिलर टू अ जिप फाइल. सो बहुत सारे कंटेंट जो भी प्रोग्राम इंस्टॉल होना है उस चीजों को वो एक साथ जिप करके रखता है. इफ यू unzip it, if you see MLS tool, this is what you will find out. Okay, that you can check again. You can download this any DMG file, any कोई भी ऑपरेटिंग कोई भी एप्लीकेशन अगर मैक के लिए डाउनलोड करते हो तो बाय डिफॉल्ट दे कम अप विद DMG फॉर्मेट. Then there are some removable media also. सो नॉर्मली बहुत सारे रिमूवेबल मीडिया में पार्टीशन नहीं होते हैं और बहुतों में पार्टीशन होता है, तो एक पार्टीशन होता है वो भी डॉस बेस्ड, बिकॉज दैट DOS partition is the simplest one. So whether you talk about like so pen drive, small pen drive, or the memory card which you use in camera or mobile phones, etc. So you have a single partition, और उसको हम again MMLS देख सकते हैं. CD-ROMs are complicated. You can see here. You can go through this. CD-ROM, although again nowadays they are not very common, but still you can get access to. So in CD-ROM, because CD-ROM has got so many standards to be written, कैसे लिख रहे हैं CD-ROM को, तो अगर वो 9660 फॉर्मेट में है, तो that can be say read into all the systems, Windows, Linux, Macs. But normally if something is written into a MacBook, and if you want to see it in window, it will be most of the time it doesn't work with. So you have certain tools you can find out here, especially with CD reader writer. पता नहीं तुम लोग यूज किए हो कि नहीं, कभी यूज किए हो रीड राइट CD में राइट करने का, मल्टी सेशन मल्टी राइटेबल
CD बर्न करना रहता था पहले, किया था.
हाँ, तो वो तो होता है कि वन टाइम बर्नेबल, कुछ आते थे CD रीराइटेबल. दो तरह के CD आते हैं, एक आता है CD रीड राइटिंग की बात कर रहा हूँ मैं, रीड ओनली का नहीं. तो एक आता है जिसमें हम एक बार राइट कर दे और फिर उसके बाद दोबारा राइट नहीं होगा.
यस सर.
दैट इज इजियर. एक बार राइट कर दिया और फिर वो जिस फॉर्मेट में राइट हुआ है उस फॉर्मेट में रीड करेगा. और कुछ रीराइटेबल होते थे, जस्ट लाइक पेन ड्राइव, कि हमको थोड़ा कंटेंट है राइट कर लिए, फिर बाद में और थोड़ा कंटेंट है फिर से राइट कर लिए. जब पेन ड्राइव नहीं थे ना, तो हम लोग उसका यूज करते थे कि भाई अगर कोई डेटा ले जाना है एक जगह से, और तब नेट भी इतना फास्ट नहीं था, तो डेटा ले जाने के लिए सबसे वही था, बिकॉज फ्लॉपी डिस्क वेर वेरी अनरिलायबल. तो मल्टी सेशन राइट्स होते थे, एक बार राइट किया, फिर थोड़ी देर बाद फिर राइट किए, फिर थोड़ी देर बाद फिर राइट किए, या एक दो दिन के बाद. तो उस केस में जैसे यहाँ पे एक एग्जांपल दिया है कि जैसे मान लो कि 3 सेशन में हमने कुछ राइट किया, जैसे एक बार राइट किया, फिर 2 दिन बाद एक और कुछ राइट किया, तीसरे दिन बाद फिर कुछ और राइट किया 2-3 दिन बाद. तो उसको अगर तुम मैक सिस्टम में करते हो तो मैक सिस्टम में तो सारा दिखेगा. लाइनक्स में जब द ऑथर हैज रिटन, although I have not tested it to be very honest, तो उसको जब वो लिनक्स में देखा था तो वो देखा कि सिर्फ लास्ट सेशन ही उसको देखा, लास्ट सेशन का डेटा, पहले 2 सेशन का डेटा नहीं दिखा उसको. और विंडोज में जब वो देखा तो सिस्टम इज वाज इनवैलिड. सिस्टम विंडो एक्सपी में ऑब्वियसली सिस्टम वाज इनवैलिड, उसमें कुछ भी कंटेंट नहीं दिखा. बट देन as he has told that कि ISO Buster करके एक प्रोग्राम इंस्टॉल किया, and then he can see all the 3 sessions. So CD as such is having a different format. But again, with MLSS program, we can see if there are partitions and how we can do. Okay, so today we'll stop here, and next day, in fact, we'll start with, I will just go very briefly with BSD partition, that means Linux partitions, and then we will move on to the file system analysis. So next part you can see in this book is, this is what I was discussing right now, volume analysis. So next part is in fact file system analysis. So next week probably we'll start with file system. So as I told, ki last 2 weeks we concentrate on disk analysis only, and how many volume, how many partitions in a disk. Now given one partition, obviously there will be something, how things are organized into that partition. I hope I am clear कि कैसे मैंने कैसे ऑथर ने लिखा है और कैसे मैं उसको बताने की कोशिश कर रहा हूँ कि हम लोगों ने पूरे स्ट्रक्चर को, डिस्क को देखा कैसे पार्टीशन है. अब एक पार्टीशन पे हम अगर कंसंट्रेट करते हैं कि उस पार्टीशन में एक फाइल सिस्टम होगा जो हम लोगों ने डिस्कस किया, NTFS या EXT. So how things are organized into NTFS or FAT or EX2 or EX3 and so on. Okay, so that's what we'll start next week. Tomorrow I will expect that everyone, I will request everyone, and find out. Otherwise you can talk to Abhishek, and